How can we tell if the structure is unstable? There are 3 red flags to watch out for. First, the structure doesn't have enough reactions. Second, all the reactions are parallel. And third, all the reactions intersect at the same point. If you spot any one of these in a structure, that tells you it's unstable. The first red flag is the easiest one to check. A structure is only stable if all the static equilibrium equations can be satisfied. There has to be at least one reaction for each equilibrium equation for the structure. 2-dimensional structures need at least 3 reactions, and 3-dimensional structures need at least 6. For every reaction short of that minimum number, there's at least one equilibrium equation that the reactions can't satisfy. If any one of the equilibrium equations can't be satisfied, then the structure has to be unstable. Just because a structure has the right number of reactions to be stable doesn't mean that it is. Let's look at a beam with 3 roller supports as an example. This is a 2-dimensional structure, so it needs at least 3 reactions. Each roller support can provide 1, so it has the right number of reactions, but this is still unstable. You've probably spotted the issue here. If something pushes sideways on the beam, nothing's going to stop it from moving left or right. With no reaction pointing along the x-axis, there's nothing that can make the net force on the beam 0 if a horizontal load is applied. That's why parallel reactions are a red flag. When all reaction forces are parallel, there's at least one direction loads can come from that the reactions can't cancel out. Something similar happens with moments when all reactions intersect at the same point. If a beam has a pin support on one side and a sideways roller support on the other, all 3 reactions pass through the pin support. This means that none of the reactions can create a moment about that point. If a load is applied to the beam that does create a moment about the support, there's nothing to cancel out that moment, so the beam will rotate. The common thread between all 3 of these red flags is that each of them leaves at least one equilibrium equation with no way to be satisfied. So the key question to ask yourself when you're checking if the structure is stable or not is, can all equilibrium equations be satisfied for this structure? If you check and find the answer is yes, both for the structure as a whole and for all of its parts, then you know the structure is stable and you can move forward with your analysis of it. It can be tempting to assume a structure is stable at the start and dive right into the calculations for it, but checking stability before you dive in can save you a lot of headache and struggle. Trying to use statics to solve for the reactions of a structure that can't actually be static takes a really long time, and it doesn't get you anywhere useful. I've been there, done that, and wished I'd checked sooner, so trust me, getting in the habit of checking if a structure is stable first is well worth it.